Okay, before I do the next problem, we need to talk about half-lives. If you're looking for the half-life, it is the length of time it takes an exponentially decaying quantity to decrease to half its original amount. So like if you've got 80 grams of something, the half-life would be how long it takes for that 80 grams to go down to 40 grams. A sub 0 is your original amount. Let's see. It says starting quantity is A sub 0. So in this formula, you're starting with some amount, and then you've got e raised to the kt. That's an exponential function. But if it's going to equal the half-life, it's going to be half of the A sub 0 on the other side. Now, what they do next is they actually solve this thing for t, but you could also solve for k. They divide both sides right here by the A sub 0. That cancels that and that cancels that. So you're just left with 1/2 equals e to the kt. And then they go from there. And they take the log of both sides, and then they change the 1/2 to a 2 to the negative first, and move the -1 out in front using that log rule, and then they divide off the k, and they end up with time equaling the negative of the natural log of 2 divided by k. However, right here, instead of dividing by t, or instead of dividing by k, they could have divided by t also. And that's what they're showing you down here on this one, that k could equal the negative natural log of 2 over t. They're interchangeable because you can divide by k or divide by t. But anyway, what they are wanting here on participation activity 17 is express the amount. They're wanting me to express the amount of plutonium-244 remaining as a function of time. Okay, they want it as a function of time. So when the original function is A equals A sub 0 e to the kt, they're actually looking for A of t. They want it as a function of time, which means I have to figure out what k is, and I'm going to be using this one right here. And they tell me, so k is going to equal a negative natural log of 2 divided by time, and time in this problem is 80 million years. I need the commas. My Mobius won't let me put them in there. So I'm literally going to type, I'm going to put all of this where the k is, right there. And when you look at Mobius, it actually, where is it? They put f of t, but that's the same thing as a of t, whatever. So I have to type in, in a sub 0 e raised to the negative natural log of 2 over 80 million times t. Now if you want, I guess you could multiply that t up into the numerator, but you know what, I'm just going to leave it like that because I like that this right here is what t is, and that would, or that thing I just circled in pencil is k. That's the coefficient on your t. So I have to go back to Mobius. All right, I need an A sub 0. That's a subscript. So I need that one. You have to type in a capital A, scroll over, delete the B, and put in a sub-zero. Don't use a O, use a 0. And then it's going to be E raised to a power, so I need my exponent guy. And E, and then scroll over to the B, delete the B, and type in, no, wait a minute, it's a fraction, so, oh, lordy B, I need an A over B. So negative natural log parentheses 2 over backspace to delete the B, 80, and then I need 1, 2, 3, 4, 5, 6, and then scroll to the right and type in a T. Okay, does that look right? A sub 0, E raised to the negative 2. Looks right to me. Oh, how do I do? Yay! Thank God. It's ugly, but it's that's the answer.